Hello, Algebra 2 students. This is Mr. Kraft coming to you from my house. Today I want to talk about multiplication of polynomials. Now, we've talked about polynomials before. It's been some time. So, just to refresh, if I had something like 3x plus 5, you could call this whole thing an algebraic expression. And each part of it is a term. Anything that's connected by multiplication is a term. Whoops. Different terms are connected to each other by addition or subtraction. So 3x is equivalent to saying 3 times x. That is a single term. Just like 3xy would be a single term, 3xyz, what have you. Okay. And 5 is a term. And of course, for a term like this, the number is the variable. The letter is the variable. I said number. I'm sorry. The letter is the variable. The number is the coefficient. And of course, you could say that even a variable by itself is understood to have an unwritten coefficient of 1. Okay, so we've discussed this before. If you had two different terms, okay, let's back up. Okay. We're talking about polynomials. So instead of using the word term, we're going to use monomial in this context. A monomial is the same thing as a term. One or more numbers, I'm going to abbreviate, numbers or it could be either or both, variables, connected by multiplication. So 6 is a monomial. Y is a monomial. 6y is a monomial. 7abc is a monomial. So monomials are essentially equivalent to what we have called terms in the past. No real difference. So then, polynomials, and this once more is review. A polynomial is just one or more monomials connected by addition or subtraction. Now, I actually had a discussion with a teacher I used to work with at a different place whether that is really a polynomial or this is a polynomial or that is a polynomial. Different textbooks would define it differently. But for what I'm using here, one term, a monomial, and this is a monomial, that's a monomial, that's a monomial, is a polynomial. It's a particular type of polynomial. So this is a polynomial. It has two different monomials, 3x and 5, connected by addition. So since it has two of them, it is a binomial. Just like mono The prefix mono means one. Bi means two, like a bicycle, two wheels. So if I had 5z squared plus 2z plus 10, this has 1, 2, 3 terms, or monomials. So it's a trinomial, where tri means 3. And of course, all of these are specific versions of polynomials. Poly means many. Mono, bi, and tri are the only ones we normally name. I mean, you could say tetra is 4, and penta is 5, and hexa is 6, and on and on and on and on. But we don't actually do those. We only do these. Okay. So what we're looking at today is how you multiply these guys. But I want to just kind of review conceptually how you add and subtract them. If you had this polynomial and that polynomial and you wanted to add them, well, it is basically exactly the same thing as collecting like terms. The reason I'm putting these polynomials in parentheses is just to make it easier to see that it's two separate units. If I just read 3x plus 5 plus 5x minus 8, that might look like a single polynomial with 4 terms, a tetranomial if you wanted to call it like that. But these are just to emphasize it as two separate polynomials, two separate binomials. And it's just like collecting like terms, which we have done. 3x plus 5x are both x's. Subtract. 5 plus negative 8. Add unlike signs. You subtract, take the sign of the larger. So there you go. Easy enough. If you were to subtract these guys, you do the same thing. You just flip signs. This distributes. It changes the sign of everything inside. So this becomes 3x plus 5 minus 5x. Minus times a minus is a plus, plus 8. 3x plus negative 5x. You subtract and take the sign of the larger absolute value and you get negative 2x. And 5 plus 8 is just simply 13. So that's what you would get for that. So addition and subtraction of polynomials is something you've done before. Sometimes they call it collecting like terms, or simplify, same thing. 6 of one, half dozen of another. What I want to talk about today, though, is multiplication. And there are several different ways you could look at this. You might first of all say a monomial times a monomial. I'm abbreviating, obviously. Like 3x times 5x. And we always use parentheses to show multiplication. Well, it's very easy. Numbers do the number thing. 3 times 5 is 15. Variables do the variable thing. X times x is x squared. Kind of got to remember your exponents. Remember, when you have two different things with the same base, two powers times each other, you add the exponents. So x to the third power, x cubed, times x to the fourth power, 3 plus 4 is 7. The reason that's important is if I had something like 5x times negative 6x, 5 times negative 6 is negative 30, easy enough. Remember, plain old x is understood to be to the first power. X times x is x squared. Well, let's change that. Let's say that that would have been Okay. Let's say that would have been 6x cubed. 3 plus 1 is 4. So this is just kind of a callback to what we've done on exponents in the past. So a monomial times a monomial is simple enough. Numbers times numbers, variables times variables. A monomial times a polynomial, like 3x times 5x squared minus 3x plus 7, or 5x times, let's just make a y's just to be different. 5y times 6y minus 8. So this is a monomial times a binomial. That's a monomial times a trinomial. And it seems to me that we've done this before. We might not have called it polynomials, but it seems to me we had multiplication of various terms. It's the distributive property. Just like if you had 3 times 4 plus 7, 3 times 4 plus 3 times 7. Well, if you would have said 4 plus 7 is 11, you would have had 3 times 11, which is 33. Well, if you broke it down, this times that, and this times that, 3 times 4 is 12, 3 times 7 is 21, which sure enough adds up to 33. You know, distributive property says you can say everything inside times whatever's outside. Now, for numbers, it's not necessary. It's probably faster to say 4 plus 7 is 11, times 3 is 33. Here we have to do this. So you don't necessarily have to write every single step out. I'm doing that in this context so that it's easier for you to see what's going on. But don't feel obligated to think you have to do that, okay? So 3x times 5x squared, 3x times negative 3x, and 3x times 7. Each of these constituent parts you just do like I showed you a minute ago. Numbers times numbers, variables times variables. 3 times 5 is 15. X times x squared is x cubed. 3 times negative 3 is negative 9. X times x is x squared. And 3 times 7 is 21. There's nothing to go with the x, so it just comes on as it is. That's the answer. This is even easier. You got 5y times 6y plus 5y times negative 8. 5 times 6 is 30. Y times y is y squared. 5 times negative 8 is negative 40, and the y just stays as is. So there is your answer. Okay. Now, the next thing is we're saying binomial times binomial, which brings up things you wrap vegetables with, i.e. FOIL, which stands for first, outer, inner, last. Those of you that had me in Algebra 1 last year, I believe we got to this, but if not, we're getting to it now. So you have 3x plus 2, for example, and 5x minus 4. Each of these has two components, binomials. FOIL is an acronym to help us understand how to do this easily, and it just means you take the first two terms. 3 times 5 is 15. X times x is x squared. That's the first. Then you take the outer, the ones all the way on the ends. 3x times negative 4 is negative 12x. The numbers times each other and the x is unchanged. Then you multiply the inner, FOIL, inner terms. 2 times 5x is 10x, and it's positive. Last but not least, you multiply the last terms. So 2 times negative 4 is negative 8. In a case like this, where you have some variable plus a number, similar variable plus a number or minus, the first term is going to be x squared or y squared or z squared or whatever. The last term is going to be just a plain number, and the combination of the result from the outer and the inner are going to be like terms that can be added or subtracted. So the 15x squared remains unchanged. Negative 12x plus 10x, subtract and take the sign of the larger absolute value, gives you negative 2x. And the negative 8, is unchanged. There is your answer. And for these guys, the answer to binomials times each other are going to give you a trinomial. Okay, I believe we've done this before. It's not that hard, so I'm not going to do a whole lot of examples on it. We can do the Google Meet if we have questions on this tomorrow. Now, last situation is a binomial times a trinomial, or something larger sometimes, but we're just going to restrict it to this. 3x plus 5 times 6x squared minus 3x plus 2. Let me change that. Something besides 2x. That's a sloppy looking 2. 2x plus 4. Now, there's two ways to do this. You can't do FOIL because there is no discrete outside or inside because they have different numbers of terms inside them. One way would be double distributive. Which works like this. I say my first term, distribute it with everything. 3x times 6x squared plus 3x times negative 2x plus 3x times 4. Then you distribute this with everything. Plus 5 times 6x squared plus 5 times negative 2x plus 5 times 4. So I just said this goes with everybody, and this goes with everybody. So 3 times 6 is 18, x times x squared is x cubed. 3 times negative 2 is negative 6, and x times x is x squared. 3x times 4 is 12x. 5 times 6x squared is 30x squared. 5 times negative 2x is negative 10x. And 5 times 4 is 20. Now, these guys are like terms to each other, or with each other, and these are like terms. So I end up with 18x cubed, negative 6x plus 30, negative 6x squared rather, plus 30x squared is going to be positive 24x squared. 30 minus 6 is 24. 12x minus 10x is 2x, and the 20 just does its thing. It stays where it's at. And there is your answer. So, let me see. Let me write the answer here. Let me do some erasing, because if I just clear the board at once, I'll lose it all and not remember what I was doing. So let me rewrite this. 3x plus 5 times 6x squared minus 2x plus 4. And let's write the answer we got. 18x cubed plus 24x squared plus 2x plus 20. And let's erase everything else out so I can show you the other way to do this. which I find to be far easier. Students don't always see it that way, but different strokes for different folks, right? But I would encourage you to be able to do it this way because it really would make life much easier for you if you did it this way. I do long multiplication. I'm going to take the trinomial and write 6x squared minus 2x plus 4. Then I'm going to take the binomial and write 3x plus 5. Notice that everything's lined up. The numbers, the variables, and the variable squared. It's just like long multiplication with numbers. The ones place is lined up. The tens place is lined up. 4 times 2 is 8. 4 times 3 is 12. Then filler 0. 6 times 2 is 12. Carry the 1. 6 times 3 is 18. 19. Then just add what you've got, and you get an answer. You know what? That's exactly the same thing here. Here, place value is based on ones and tens and hundreds and thousands and stuff. Here it's based on degree. That means the exponent. Second degree, first degree, 0 degree. So 5 times 4 is 20. We do have to put a plus sign. We don't do that. We don't say 100 plus 20 plus 8. We don't do that, but we have to do it. 5 times negative 2x is negative 10x, and 5 times 6x squared is 30x squared. Filler 0. Then 3x times 4 is 12x, and then that's positive. 3 times negative 2x is 6x squared, which is negative. Then 3x times 6x squared, 3 times 6 is 18, x times x squared is x cubed. Now, 20, negative 10x plus 12x is 2x, and is positive. 30x squared minus 6x squared is 24x squared, which is positive, and the 18x cubed drops down. And you know what? You got exactly the same thing that you did by the other method. Now, the other method I showed you, double distribution, to me is much, much harder. To me, this here, long multiplication, is so much easier. But I do have students that find it difficult. I would encourage you to be able to do it both ways, and I would encourage you to do it this way, but that's okay. I think that covers us for now. I will see you the next time, and until then, I hope you have a good day.